All right, so obviously I think I need to change my LeetCode strategy because what I'm doing right now isn't really working. I think what I'm going to do going forward in the future is instead of looking at different problems within a whole wide variety of uh, different topics, I'm going to just focus on one specific type of problem and I'm going to get really good at that type of problem. If I get a question which is this type of problem, I should be able to solve it. That's what I'm going to be doing. That's how I'm going to be practicing. I'm going to just tackle one specific type of problem and then once I get really good at it, then move on to the next one, systematically doing it that way. And this way, if I get this question, any question within this topic, I can solve it. Then I move on to the second topic and I get to the point where any question within this topic I can solve. So now I am going to do depth first search. So that's what we're going to be doing going forward. And last time I tried to do a medium, which was depth first search, I got destroyed. That was yesterday. That was yesterday's video. Today, we're going to be doing an easy. So I've already done some easies. That was a while ago. I can't really remember too much of this. I'm going to try maybe this one, Symmetric Tree. Let's see how this one goes. All right, so Symmetric Tree. Have my coffee here. Easy. Okay. Given the root of a binary tree, so we're given this root, check whether it is a mirror image, i.e. symmetric, around its center. Okay? So I have this node, which is the root node, and it has two children right here. And I notice both of them have a value of 2. So not only does the shape need to be the same, but the value within the nodes need to match as well. So 3, oh, wait, hold on. 2, 2, but then this one has 3 and 4. This one has 4 and 3. But it says true. Check whether it is a mirror image of itself. Okay, so actually, updating what I just said, I think it only matters the shape, because in this one, the shape is the same, but the numbers are different. No, I just realized 4, 4. So, okay, so this one's right child and this one's left child are the same. This one's left child and this one's right child are the same. Okay, so that's what it means by mirrored over the axis. Okay. This one is going to return false because you come here. Obviously, I can just tell by inspection that the shape is different. But I'm looking at this one and I'm looking at this one. They both go kind of like this, where they both have a right child and no left child. So that's not the difference. The numbers are the same. Okay. Follow-up, could you solve it both recursively and iteratively? So that means that there is a recursive answer and an iterative answer, which kind of makes sense when we're traversing a tree. We should be able to have both an iterative and a recursive. I'm going to try to figure this out with a recursive method. Okay. So I understand the problem. I see what it's asking. Now I am going to try to think of strategies for actually accomplishing this. I'm given a node, and I know that I will have to do recurse, okay, and it's going to take in a node. And what do I want to do in this recurse function? Come down here, come down here. So I need to go both to the left and to the right. So maybe like if node dot left okay, not, I'm trying to think of my base cases. So let's say I'm obviously I can traverse the tree by doing something like this. So if node dot left recurse node dot left, if node dot right recurse node dot right. Okay. I know that I can traverse the tree by doing this arrangement, but I need some way to keep track of its mirror image. So like here, here. So I'm going to first be going left. So I go here, then here. I'm also noticing that it is not asking for symmetric coherence from all sub trees. What I mean by that is, look here. So this node has symmetry. So 2, 2, 4, 4, 3, 3, just like you're looking in a mirror. Okay. But here, if you put a mirror here, you have 2, good, but then 3, 4. So this sub tree does not have symmetry, and it's returned true. So that means that the only mirror image that matters, the only symmetry that matters, is the root node itself, which, I'm trying to think how to shoehorn that into recursion. Is there possibly an iterative way that I can do this? Because the thing that I'm getting caught up on right now is I know how to recursively do a depth first search on a tree, but I'm not sure how to keep track or keep memory of the path in which I went unless I do something like I create a list up here, like visited as an empty list, and then I can do like visited.append, and then node.left.val, the value of that. And then when I pop back up, can I like call two functions? Okay, what I'm thinking, I might be able to do something like this. I have a function which is recurse right, which takes in the root node. Then I have a recurse left, which will also take in the root node. Then within these, so what I'm thinking about doing is calling two recursive functions. And what I'm going to be doing in here is I start at this root node, and then I call recurse right, or actually I can call recurse left first. So I call recurse left, and I come down here, and then down here, and then up, then down, then up, up, and then I return. I do not, yeah, I can terminate at here. I can check if it's the root node, and then I just terminate. Once I've gotten back to the root node, I just terminate. Okay. Then I keep track of this depth first search. So I come here, 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 up, here. I keep track of it in visited left, and then I have another one for visited right. I have another one for visited right. So I'm going to do the exact same thing, but in the mirrored direction. So now I go right here, and then I go right here, and then I pop up. I come down here, and notice I did the exact same. I did the mirror. So this one I did left, left, left. It's mirrored. The video, I mean, is mirrored. Left, 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 up, right. Here I did right, right, pop up, left. So I'm going to mirror them, and then once I've called both functions and I popped back up, then I can check if the visited left is equal to the visited right. Okay, so that's how I'm going to do it. Okay, so visited right. How do I want to go about performing this? So I'm going to be passed in this node, and I want to first go right. So if node.right recurse right with node.right, and we're going to fix our base cases because we obviously need base case. Well, actually, like in this case, we didn't need base cases because there's a implied base case. If we don't have a left and we don't have a right, then we just end, right? Like in here, once we get to this 3, this if statement is not going to trigger, and this if statement is also not going to trigger. So we're going to pop back up. Now we're back at this one, so then we do there is a write. So we go here, but then this one, not trigger, so you pop back up, and then we just came out of that one, then we come up. So you don't necessarily need a base case because there's an implied base case here, but we will need a base case in this situation because I need a way to terminate immediately when I get back to the root node. We'll figure out how to do that later. Okay, so I want to recurse write, and then if node dot left, I'm going to recurse. Now when I say recurse write, what I'm meaning by this is on the right side of the tree, but we're actually going left. So for example, I'm on the right side of the tree, I go right, up, and then I go left. So I go left on the right side of the tree. Okay. Now, when I go right, I want to immediately add this node to the visited list. So what I'm going to do is I'm going to come here, I'm going to add this. So it's going to be 1, 2, 3, 4. Then here, 1, 2, 3, 4. I'm just realizing if there was a 4 right here. So let's take this node away and let's put a 4 here. The visited array that I would get would be 1, 2, 3, pop up, then 4. Then I would get 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Both would be the same, but the structure is different. So, possibly that's not going to, either it's not going to work or it's not the full solution yet. And I don't know which one. Coffee in one hand, water in the other. Okay. How do I keep track? The immediate idea which I'm having right now is to, instead of adding just a number, what I was thinking about possibly I could do is I could have a list of like tuples. Whoops. Kind of like this, where I have like a value. So this would be 1, 2, 3, but then I keep track of right or left. So I do 1, 2, 3, and this is going to be left. So maybe 2, and then left, then 3 left, then 4 right. But that's not very descriptive again, because this 4 right could mean that this 4 is a right child of 3. or it is a right child of 2. And both cases would be hit in the exact same order for depth first search. So 2, 3, 4. So it'd start here. So actually it would be 1, but okay. 1, 2, 3, 4, and 1, 2, 3, 4. If 4 was a right child of 3. So both would have the exact same order and orientation in terms of it would be a right child, but we don't know a right child of which node, and that is extremely important for this case. So what I just said right there will not work, the tuple method. Mm-hmm. At least on this one, I feel a little bit better. I'm not sure how to do the algorithm, but at least this one I understand the question. The yesterday's problem, absolutely, I was so kind of like depressed about because yesterday I didn't know how to do the algorithm, but I didn't even know how to. I didn't even understand what the question was asking. At least this one, I can understand what the question is asking. I'm just having difficulty figuring out how to solve it. So. Hmm. This is an easy right here. This is an easy. I should. Okay. Apparently, I have a lot of work to do. And if you saw up here, I had already solved depth first search questions. Now, admittedly, this was a while ago. I can't remember solving sane tree or balanced tree or minimum. I can't remember solving any of these trees. But it should be somewhere in like my subconscious. But it's not. Well, it is, maybe. I don't know. But I can't figure out how to do this one right here. I cannot think of how to actually keep track of those. Because if it was just I wanted to figure out the mirror image of each node and each node within its subtree, right? Like if this subtree also needed to be symmetric, that one I could just do in one recursive function. I would just call traverse left and then traverse right and see if the returned value for both of them is equal. If so, bam, keep recursing. If I find any instance where it's not the case, let's say that this 2 doesn't even exist, I'll recurse down here, then recurse down here, then come up, and now I got at this node's recursive stack, recursive call, I've just gotten back 3 from recurse left. Then I come here, I get, let's pretend it's 3. I get 3 back, okay? Then it comes up here and says 3 and 3, recurse left, recurse right, bam, we got it. Keep going. Then come up here. So now I'm at this one's. So I just got back 2. Then I come here and say, oh, null. So then I can immediately say 2 and null are different, therefore throw it out. But that's not the case. in this one because we don't have symmetry on every subtree. Do I have any more coffee? It's out. We don't have symmetry. All right, let's go to GPT and figure out how to so conclusion of the video, I wasn't able to solve it. We failed. I failed. But now is the extremely important time for investigating this question, figuring out how to do it, what data structures are used, and understanding the problem. That way, if I see this problem again or something similar, I have an understanding of the concepts, the data structures, the actual algorithm, and the conception of the problem to be able to move forward. So now is the important part. So result of the video, failed. Time to investigate. Again, it kind of feels bad to fail at easy questions, and I don't feel like this is a very difficult one. So it's kind of like, oof. But, you know, it is what it is. So here, this is yesterday's question. This is the one I couldn't even understand. So, what was the problem number 101? Was it symmetric tree? Yeah. METR tree. Okay. Show me the answer and actually let me just do tell me which data, tell me how you would suggest keeping track of the path. Let's ask it this way. I should have said don't give the code. Okay. So recursive approach. You can use a helper function to compare the left and right subtrees. The base case would be when both subtrees are none, indicating symmetry at that level. Or when either subtree is none, indicating asymmetry. But I don't think that's right. See, this is what I was thinking about doing, but that implies that there's symmetry at all levels. I don't think this is right. I can even just like test it out, see. Copy it. And then paste it. Let's see. I don't think it's right. Is mirror, yeah. If it is right, I'm going to be a little bit like, solution is mirror. Wait. Takes one positional argument. Oh. Hold on. How did it do it? I see. Okay. This one. All right. Oh, I hate this. Copy. Now, is mirror here. All of this is tabbed over. Okay. What? It's right. But doesn't this imply that there's symmetry at all levels? Do don't okay, let me okay. So, we do this is mirror, okay? And we pass in the root twice. Here, here. Now, if not left and not right, return true. Okay, that's the base case where if we don't have this node and we don't have this node, it's just true. And we're also going to return true for here and here. So this returns true. Then this comes up here. Actually, I don't know that yet, but I'm just saying this would be true if we're recursing here. So now, if not left or not right, return false. So I come here, I go down, and so actually, if not left and not right, oh, I see. No, I don't see. Because for this one, it would be true because there's not a left or a right, so we return true. But what about if this didn't exist and this one didn't exist? So this is true, then this comes up. So if not left, that doesn't trigger. And, or not right. So now all of a sudden this one becomes false. So this 2 returns false back up to here. So this one has, where is it getting called? Left.val equals right.val. So I'm calling it right is mirror left, right, right, left. I'm trying to figure out where this, so I'm assuming that this is going to return back false, but I am trying to figure out where and how this function is actually being implemented. I wish I had more coffee. Okay. So let me just look at this statement here. Is mirror. What am I passing in? I'm passing in the left value of right. Okay. So left, right, right, left. So I guess I'm just gonna have to walk through this. Hold on a second. So I have 1 here. So right now, left and right both equal 1. So then I come down here. No, I don't come down here. Sorry. I look, is there a left? Is there a right? So yes, yes, so that doesn't hit. And then this one also doesn't hit. So then I come here, return left value 2 equals right value 2. So that's how I'm checking symmetry. Okay. Along the node or along the roots mirror, and so that's just 1 layer down, and is mirror. So I'm calling myself left, left's, right, and right's left. Okay. Then I'm calling on left's left and right's right. So now I'm going 2 layers down. So I'm still at this node's recursive call. And I'm checking this value and I'm checking this value. Then I'm going to do recursion, but not on this value. No, I'm doing recursion on this value and then this value from this one's recursive call. Very interesting. This is actually kind of an interest. Apparently, it works. I kind of actually want to submit it to see if like it works on all cases. But so far, I think this is actually kind of an interesting thing. I never thought about doing recursion on 2 layers down. Like you're not doing recursion on the next layer, but you're doing one on the layer below that. Very, very interesting. Why you would be doing this. Okay, so that's it. I guess right now my level of not level of confusion, my point of confusion is I'm trying to understand why do you just return false if a node doesn't have a left or a right? It doesn't say that it needs to be like a full binary tree. If this node didn't exist and this node didn't exist, it would still be symmetric along the root nodes, along the root node, right? Yeah. So I come here I'm right here. I look at this value. I do a peek. I'm not actually traversing down there. I'm just doing a peek and saying, okay, yeah, this is 2, and that equals 2. Then I'm actually doing recursion, and I say is mirror of left dot right, left dot right, which is null. I said this doesn't exist, so we get null, is mirror of null, and then right dot left, which is also null. I said this isn't there and this isn't there. Both are not null. So is mirror of null and null. This one is not very interesting. This is left, which is, and then right. Okay, that one's not very interesting. This is the one I'm interested in. I just passed in that I'm going to go back up here, and I'm passing in null and null. So if not, okay, this means if not, so I just passed both are null. If null and null. Okay, then I return true because both are. But if this one existed and this one did not, I would pass in 4 and null, which would, bam, break it. Then I would return false. Okay, that makes sense actually. And then I come here and say left, left. So I come bum, bum. So 3. And then come here and 3. So I'm passing in this node and this node. So this doesn't trigger because by left, okay, I think I see a little bit of where I was having some difficulty understanding. When it says left, it doesn't mean the current node left child. It means left as in the left side of the tree, the right side of the tree. Okay, I think I see my confusion on this problem. That's actually, I like this problem. This is a fun one. This is a fun one. Okay, the other ones were like depressing for me because I was just like, I can't even understand what's going on. This one, I feel like, even though I wasn't able to quite solve it, at least I'm like, okay, I can move forward. I can understand it. I'm learning, right? Move it. I like this. Okay, this one is a fun one. I like this problem. So, left and right just mean on which node, and we have 2 nodes and we're comparing them. So if one is null and the other one has a value, you know that it's not symmetric and you can just return false. If both of them are null, then okay, return true. Now I come here and I check. Okay. So if so this and this and this, you're just checking if you passed in a null value for both of them, or if you passed in one has a value, the other one doesn't have a value. Then this long expression here is just continuing to recurse, and you're doing left. Now you're checking the value because you know, I know that, and actually the first call is not going to be 2 and 2, it is going to be 1 and 1 because you're passing in root and root. Okay, I got that wrong too. So the current node, we're checking the right side of the tree, the left side of the tree. We're seeing if, great, does this value, is it the same? Yes. 1 and 1. Good. Now, what are we going to do? Is mirror. So now I'm doing left and right. So now I am going to check left. So left's right. And I pass this value in to the call. So apparently I'd never pass this to. No. I keep messing up because that left is the current node. So I do root left, which is 2. Okay, things are starting to fall into place. Things are starting to fall into place. So I do 2. Actually. 2 and 2. So then, okay, I'm not recursing 2 down. I'm just recursing 1 down. So is mirror. So I'm looking here, and I am going to be doing the right value and the left value. So this one's and this one, because we're both looking at this root. So now when I call this function again, so I'm doing recursion from this call, but this call keeps track of both sides of the tree. So because this left and this right and this left correspond to this left and this right. So now when I'm doing operations within the call, or this problem, I'm looking at this node and I'm looking at this node. So then I say, okay, is this null and this null? No, that is not the case. Now, is this null or this null? No, that is not the case. So now I say, okay, does this value equal this value? If yes, continue to see if we have a hit. If no, just return false. But these two values are the same. So then I say, okay, great, let me then do this. Let me go to the left. So that means we have 2 nodes. This is left, this is right. So let me go to left, right. And let me go to right's left. Now, when I do the recursive call again, I come back up here, I'm looking at this node, and I'm looking at this node. We do the same thing, but is this null and this null? Nope. Is one of them null? Nope. Is this value equal to this value? Yep. So now I'm going to take this value and I'm going to put its right, and I'm going to take this value and put its, hold on, so left, right, and this value's left. Yeah, right, left. And then it's going to come back up here and say both are null, so I'm going to return true. So this returns true, this returns true for these 2 nodes, this node and this node. Then this one will hit, and we're going to check this one. We're going to check 4, which is left. So left's right, and right, sorry, left's left, and right's right. Both are going to be null, which triggers this one. So we get true, true. So now we have true, true, true. So now we return up back to this one, which this one's calling was right here. And we just got true. So 2 and 2, this one is true. So now we're going to check its, now we're back up here. This one is left, this one is right. So now we're going to check left's left and right's right. So now we pass in 3 and 3. Come here. Nope. Nope. And then are they the same? 3 and 3? Yep. Correct. This one will return true because it's null and null. This one returns true and true, so we're null because null and null. So this one passes up true. So now we have true, 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 and true on the 2 level. Then we come back up to the 1, and we had this one was true, and this one was true, and this one was true, because this returns true and this also returns true. So now the entire thing is true. Okay. So as of right now, looking at the code, I am able to understand how it's working. I'm trying to be honest with myself and ask myself, could I have come up with that answer? I don't know about that. So I definitely need to study more of this depth first search and try to figure out and try to train my brain of the methodology for actually achieving and accomplishing breadth first search, because I don't think, or depth first search, because I don't think I could have actually pulled that out of my hat. It's a very interesting problem. I'm glad I like this. 101. It's a good problem. I'm glad I did it. I think that this is something that I'm going to keep looking at, this specific problem. So as of right now, I am going to end the video and I'm going to get back on and I'm going to do another video of, well, first I'm going to study this problem a little bit more, and then I'm going to look into depth first search a little. I'm mixed on that. Should I do another video immediately, or should I study depth first search? Because what I'm thinking is, do I need more problems, or is there a misunderstanding of a concept? If there's a misunderstanding of a concept, I need to go study that concept. If it was just I didn't know how to solve this problem, I need more problems. Okay. I'm gonna make more coffee, and then I am going to attempt another problem. So I'm gonna be back in a little bit with another video, and I'm going to keep solving these LeetCodes. So thank you so much for watching. My name is Timothy Lee Grant. If you want to subscribe, that would be awesome. And thank you for watching this video. Have a good day. See you in a few minutes.